This is Lab 4 for Physics 2211 on oscillations. The purpose of this experiment is to compare the predicted and observed motion of a mass oscillating on a pendulum and plot the energy changes of the model compared to the experiment. In this lab, I will analyze a video of a mass oscillating on a spring. I will compare my experimental data of energy change to the computational model in GlowScript. So some fundamental physical principles are the energy equations, UG equals mgh, US equals 1/2 kx squared, and kinetic energy equals 1/2 mv squared. And then the conservation of energy principle, which is that the energy in the system initial equals the energy in the system final. And I've chosen the system to be the spring, mass, and Earth, because I wanted to include gravitational potential energy, and if the system is the Earth, you can include that, and if it's not, then it's just work done by the Earth, which makes everything more complicated. The final two fundamental physical principles in this lab are the force of gravity, F equals mg, and the spring force, F equals negative kx. And these are used to calculate the change of position of the mass on the spring. So some initial conditions: the mass of the ball is 0.402 kilograms, and the spring constant is 6.83 Newton meters. I analyzed the videos, so I got given these. And then for my system and surroundings, I chose the system of the spring, mass, and Earth to be able to use gravitational potential energy, and my surroundings were the hand, the arm, pivot point, basically everything that's not the system. And this is a video of the experiment. He just lets go of the mass, and it's just moving around on the spring. So my model is this. My constant to calculate the gravitational, my G is 9.8, spring constant is 6.83, the relaxed length of the spring is 0.123 from, which is given. I used L is the ball position minus the spring position, which is basically just the current length of the spring. L hat is L over magnitude of L by definition. And then S is basically X in the spring potential energy equation. The next four lines have to do with energies, so kinetic energy, gravitational potential energy, spring potential energy, and the total energy is just the sum of all of the energies. And so in the actual loop, we define the initial energies, we calculate the gravitational force, we calculate the spring force, and then the net force is just the sum of the forces. We update the velocity and position using Newton's second law and the position update formula. And then we update the spring using the spring force, and then we calculate the new energy changes and find delta E, which we then apply for the next round. This is my graph. It's messed up. I think my model is right, but I'm not really sure how this is correct. Sources of error. Human error in model code. I'm pretty sure I did the code wrong because I don't think that my graph looks how it should. But other than that, like in the video, if the person started moving the block with the initial velocity, then it would not be the same as the model predicts. But I'm pretty sure the main source of error is that my code is just incorrect. Is the energy principle satisfied? Yes, since the system is the spring, mass, and Earth, energy is conserved and E stays constant on the graph. That's the one thing that it does in my graph. And then period of oscillation from X, 1.7 seconds. Period of oscillation from Y, 0.45 seconds. And the reason for this difference is, I'm pretty sure, because I've messed up my Y-axis. It should be the same. It's just being difficult. Conclusion. I analyzed the video given of a mass oscillating a string. I input X and Y position data into my Wissert model, which allowed me to model the oscillation through code. I created a model with the forces and energies, and then I compared the model to my experiment.